Now, the binomial theorem. We can state it this way. X plus y raised to the power n is equal to n choose 0, that's the first coefficient, times x to the power n times y to the power 0. Y to the power 0 is 1, but I'm just writing this to see the pattern. And then next you have n choose 1 as the next coefficient, n choose 2, and so on. You keep increasing how many you choose up to n choose n. At the same time, the power of x goes down one at a time, and while the power of y goes up. So here n is reduced to n minus 1, and y goes from 0 to 1, and then n goes down to n minus 2, y goes up to 2, and so on. And finally at the end you get x to the 0, y to the n. So there is a symmetry involved. The first and the last one are symmetrical if you just switch the x and y. The second and the one before the last, those two are symmetrical if you switch the x and y, because the binomial coefficients, these coefficients, which are combinations, and we talked about in the previous video, they are equal. These two, and then n2 and n minus 2 are equal. Let's look at an example. X plus 2y raised to the power 6. Here the x is x, the 2y is y. You know, they don't have to be always just a single symbol. They can be a multiple of a variable like 2y, or they could be positive or negative, you know. So if we follow the binomial theorem, the above formula, you get 6 choose 0 because n is 6, and now you choose 0, and then 6 choose 1, 6 choose 2, all the way to 6 choose 6. Those are the coefficients. And again, the first term in the binomial is x, that has a power, and the second term is 2y, that too has a power, and the powers work against each other. Starting with the first term, you have x to the highest power, 6, and 2y to the lowest power, which is 0. 2y raised to 0 is, of course, 1. You can simplify that later. And then the power of x goes down by 1, while the power of 2y goes up by 1. And this continues all the way to the end. And we can simplify this. We can find these binomial coefficients using the combinations formula. So for example, first of all, 6 choose 0, we know it's 1. Okay, let me write it. So here 6 choose 0 is 1, and 6 choose 1 is 6. You can use the binomial formula for it, but those are easy to see and they're nice to know without any computation. Now let's do 6 choose 2. 6 choose 2 is 6 factorial divided by 2 factorial times 4 factorial, and that can be reduced. The 6 factorial is 6 times 5 times 4 factorial, right? It's not necessary to list all the factors. After 5 you have 4, 3, 2, 1, but from 4 down is just 4 factorial. And I'm going to put it in parentheses. in the denominator you have 2 factorial times 4 factorial, and now you can reduce the fraction by dividing by 4 factorial. So what you get is 6 times 5 divided by 2. 2 factorial is just 2 because 2 times 1. 6 divided by 2 is 3. 3 times 5 is 15. So 6 choose 2 is 15. Now 6 choose 3 is 6 factorial divided by 3 factorial times 3 factorial. And that's equal to, so here you can write similarly to previous one, you can write 6 factorial as 6 times 5 times 4 times 3 factorial. Because that way you can simplify it with the 3 factorial below it. And then the 3 factorial, the first one in the denominator, is 3 times 2 times 1. So these 3 factorials cancel out. And now in the denominator you have 3 times 2 is 6. That cancels with the 6 above. Then you get 5 times 4, which is 20. Okay, so these can be done without calculator. You know, they're easy to simplify. And then the next one would be 6 choose 4. And that is the same as 6 choose 2. You know, because of symmetry, 6 choose 4 is the same as 6 choose 2. That is always the case because 4 plus 2 is 6. And 6 choose 2 we found above, and it's 15. And then 6 choose 5 is the same as 6 choose 1, which we know it's 6. And similarly, 6 choose 6 is the same as 6 choose 0, which is 1. So the coefficients are 1, 6, 15, 20, 15, 6, 1. Okay, so now we can continue here. So this is equal to 6 choose 1, 6 choose 0 is 1. So you just get x to the 6th because 2y to the 0 is 1. So that first term is x to the 6th. And then 6 choose 1 is 6. So it's plus 6 times x to the 5th times 2y to the 1. You don't need to write the exponent 1. And that is plus the next one, 6 choose 2. 6 choose 2 is 15. So that's equal to 15 multiplied by x to the 4th. So we are here. Times 2y to the 2nd power. That would be 4y squared. And the next one is plus 6 choose 3. 6 choose 3 is 20. Okay. And that is multiplied by x to the 3rd power times 2y to the 3rd power. 2 to the 3rd is 8. So that's 8y cubed. And then plus 6 choose 4. That's the same as 6 choose 2, which is 15. We have it here, 15. So that's 15 times x squared times 2y raised to the fourth power. 2 to the fourth power is 16 times y to the fourth. And then plus, the next term is 6 choose 5 is just 6. X to the 1 is just x. 2y to the fifth, 2 to the fifth is 32. So that's time 32. Y to the fifth power. Plus 6 choose 6 is 1. X to the 0 is 1. So you just get 2 to the 6 times y to the 6, and that is 64 times y to the 6th power. And then you can simplify, multiply those coefficients that you need to. So like here is x to the 6th plus 6 times 2 is 12. X to the 5 times y plus 15 times 4, which is 60. X to the 4th y squared, and then plus 20 times 8 is 160 x cubed. So that and then you have y to the 3rd power, right? Okay, where was I? Here. Okay, y to the 3rd. Make sure the exponents should add up to 6. Here's 6, 5 plus 1, 4 plus 2, 3 plus 3. And now the next one is plus, that's the one with x squared. So 15 times 14. We previously had 15 times 4. 16 is 4 times 4. 4 times 15 is 60. Now we need 4 times 60. So that makes 240 x squared y to the 4th. And the next one is plus 6 times 32 is 192. So that's x times y to the 5th, plus finally 64 y to the 6th. All right, so we applied the binomial theorem to expand this and used the binomial formula, which are these, and these are combinations. The next, we want to see the relationship between the binomial coefficients and combinations. So here's an example. I just use x and y to make it simpler. And x plus y is raised to the 5th power. That means you have x plus y times x plus y times x plus y times x plus y times x plus y 5 times, right? So how do we multiply this out? We can do 2 at a time, and then the result by the next, and then the result by the next, and by the next. But eventually, think about this. No matter how you multiply all these together, you have to choose from each of these factors either the x or the y. For example, from the first factor, I can choose the x. From the second one, x. From the third one, y. From the fourth one, x. From the last one, y. You know that? And that gives me some power of x times some power of y. And the powers are clear. We know the highest power of x would be 5. The highest power of y would be 5. And the total should also be 5 because there are only 5 factors. So the question is, for example, if I want at some point x squared y cubed. So I want 2 x's to multiply by 3 y's. X, y, y, y. But they don't have to be XX, they don't have to be the first 2, and y, y, y don't have to be the last 3. You know, they can be in any position. So that's where combination comes in. So here I want to find, I want to choose 3 y's. So I can choose that among all these 5 factors. Any of the 3 you pick, you get one of these. And then you pick another combination of 3 y's. But of course, every time you choose 3 y's, the remaining 2 would be 2 x's, right? Because you have to have 5 factors. So how many ways can I choose out of 5 y's, 3 y's? And that's where this combination comes in. And this is exactly why for the first one you get, you choose no y's, so 5 choose 0. And now we give you x to the 5th power, y to the 0. And then the next, you find how many ways you can choose 1 y. There is 5 ways, or 5 choose 1, x to the 4th power, and then just y to the 1st power, 1 y. And then how many ways I can choose 2 y's out of these 5 factors. And that gives me 5 choose 2 times x to the power 3 y squared. And then choose 3 out of 5 y's. So you get 5 choose 3 times x squared, y cubed, and so on. So then the next one would be 5 choose 4 times x times y to the 4th. This is where you choose 4 y's out of 5. There are this many ways, and then which is 5, the same as 5 choose 1. And the last one would be 5 choose 5. This is where you choose all of the terms to be y's. From each of the factors you choose the y, no x's, x to the 0, y to the 5, and that's how you get. So just to make this clear, this is choosing, this is how many ways. This I'm just using 5 choose 3 as an example. How many ways to choose 3 y's out of the 5 factors. The remaining 2 would be x's. The remaining 2 would be x's. Okay, and that's what gives you the powers. You know, you have y, 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 and x, x. All right, and this shows the connection between the binomial coefficients. The coefficients you have to put in front of each monomial. These are all called monomials. When you have one term with powers of x, y, you can have more than one variable, but they have to be multiplied. So each of these are monomial, and the whole thing would be a polynomial. And you get a polynomial by raising a binomial to its power. Okay, x plus y is a binomial. This is the fifth power of binomial, and by the binomial theorem, this is how you expand it. So this way does not require generating many rows of Pascal triangle to see these coefficients. We saw in the first video how Pascal triangle is related to these coefficients, where you can get these coefficients in each of those rows. This is for the row 5, because the power is 5. In the row 5 of Pascal triangle, you get all these coefficients. So in this case, for example, this one, 5 choose 0 is 1, 5 choose 1 is 5, 5 choose 2 is 10, 5 choose 3 is also 10. These are the same because 2 plus 3 is 5. 5 choose 4 is 5. 5 choose 5 is 1. So you get 1, 5, 10, 10, 5, 1. And those are the coefficients in the fifth row of the Pascal triangle. So this concludes this lesson on the binomial theorem.